Okay, so this is a screencast to show an example of how to use the factor label method in doing stoichiometry. So this is different than the BCA method, although it is the same steps, it's just all sort of put together into one. So starting with this problem, lithium hydroxide reacts with hydrobromic acid in a double replacement reaction. First thing I need, as always, is a balanced chemical equation. So I'm going to start with lithium hydroxide reacts with hydrobromic acid in this double replacement, which will make lithium bromide and hydrogen hydroxide, which is just water. It's asking if we start with 10 grams, you notice this is already balanced, 10 grams of lithium hydroxide, how many grams of lithium bromide will be produced? So we start off with the thing we're given, 10 grams lithium hydroxide, 10.0 grams lithium hydroxide. And then what we're going to do is we're going to multiply that by various factors until our labels end up correctly. That's why this is called factor label. So the first thing I need to do is I need to convert grams lithium hydroxide to moles lithium hydroxide. So I'm going to do that by using a conversion factor. I know that 1 mole of lithium hydroxide in grams is equal to 16 plus 7 plus 1. So 24. 24 grams, and I got that from the molar mass off of the periodic table. So notice that now my lithium hydroxide grams and my lithium hydroxide grams have canceled, and I've converted into moles. Before I hit calculate though, I'm going to do my next conversion. I need to get from moles lithium hydroxide to moles of lithium bromide. So I know that from my equation 1 mole lithium hydroxide is the same as 1 mole lithium bromide. Those two cancel. So I'm up to 1 mole of lithium bromide. Now I need to convert finally the lithium bromide to grams. From my molar mass, I see that lithium is 7 and bromine is 80, so that's 87 grams. So my moles lithium bromide have canceled my moles lithium bromide. Alright, so now I can use my calculator. I'm going to type in 10 times 1 divided by 24 times 1 divided by 1 times 87 divided by 1, which gives me much too big a number. 10 divided by 24. My calculator is doing crazy things. 36.25 grams lithium bromide. So the steps that I took there for a mass to mass problem, I go from grams of A to moles of A to moles of B to grams of B. So I have 1, 2, 3 conversion factors. 1, 2, 3. How do I know which number goes on top and which goes on bottom? Because I'm canceling units here. So if grams of lithium hydroxide start, that has to go on the bottom. If moles of lithium hydroxide are on the top, it has to be on the bottom in the next one. Because I'm basically multiplying by fancy forms of 1. The FFU, fancy form of 1. Since 24 grams of lithium hydroxide is equal to 1 mole of lithium hydroxide, two things that are equal and they're divided by each other equal 1. So let's do another example. Ethene combusts to produce carbon dioxide and water. C2H4 combusts with oxygen to produce carbon dioxide and water. Balancing this out, I'm going to start with my carbons. I have 2 on that side. Hydrogens, I have 4, so I'm going to put a 2 there. Now I have 4 oxygens plus 2 oxygens is 6, so if I put a 3 there, I'm balanced. Starting out, I know that I have 45.0 grams of ethene, C2H4. And again, I have to do 3 conversion factors, just like the previous problem, because I have to go from grams of A to moles of A. So I know that 1 mole of C2H4 is equal to 28 grams. From the periodic table, I know that carbon has 12 grams, and there's 2 of those, so that's 24, plus the 4 from hydrogen makes 28. Now I need another conversion. I gotta go moles to moles, so 1 mole of C2H4. No, it's not 1 mole. Yeah, it is. 1 mole of C2H4 is to 2 moles of carbon dioxide. And now I have to convert to grams of carbon dioxide. It's 44 grams, right? 32 2 plus 24, sorry, plus 12 is 44. 32 plus 12 is 24, is 44. All right, so when I calculate this out, I take 45 divided by 28 times 2 divided by 1 times 44. It gives me 141.4 grams carbon dioxide. Let me double check that because I didn't see that. 45 divided by 28. Yep, 141.4 grams carbon dioxide. Third example problem. Magnesium undergoes a single replacement reaction with sodium fluoride. So to balance this, I do the following. And I want to now calculate. If I start with 5.5 grams of sodium fluoride, how many grams of magnesium fluoride will be produced? Same three conversion factors. 1 mole of NaF is equal to 19 plus 23, 42 grams NaF. Second conversion factor is going to be the mole to mole ratio. So I know that I have 2 moles NaF to 1 mole magnesium fluoride. And finally, I'm going to convert from moles magnesium fluoride to grams. Magnesium is 24, fluoride is 19. There are 2 of them. So that gives me 62 grams. Calculating out, I take 5.5 divided by 42, 2 times 62. Tells me I'm going to make 4.1 grams magnesium fluoride. Hydrochloric acid reacts with sodium sulfate in a double replacement reaction. If you start with 20 grams of hydrochloric, how much sulfuric will you add up with? Hydrochloric acid reacts with sodium sulfate to produce sulfuric acid and sodium chloride. Balancing this, put 2 there, and I'm balanced. So I'm going to start with 20 grams of hydrochloric acid. Same 3 conversion factors. 1 mole of hydrochloric acid is equal to 36.5 grams. The mole-to-mole ratio now, we know that 2 moles of hydrochloric acid gives us 1 mole sulfuric acid. Now I need to convert to grams sulfuric acid. And 1 mole H2SO4 is equal to 64 plus 32 plus 1, 97 grams of sulfuric acid. So if I do my multiplication now, 20 divided by 36.5 divided by 2 times 97 gives me 26.6 grams of sulfuric acid. All right, so that's 4 examples of the factor label method of